Okay, sorry. Um, all right. So, confirm you can see the slide.
Yes.
Yes, we can see it.
Okay, okay. So basically, we are talking about hazardous area classification. Okay, now this is a free session, and this is actually a topic that Mr. Gibbs has been meaning to actually discuss on, right? I think it's been since on by December last year. We've been planning on taking this particular discussion. Okay, but because I was busy in terms of the offshore training that we've been doing, so we have to keep on, pushing it, and then we just decided to do it today. Currently, I'm working, and in about 3 hours time, I will need to just get to the control room and get to, because we are starting our plans. But we just have to quickly do this today, because I know by the time I get to my base at home, I will start up again another training session again, so there will not be time. So I say let's just do this. So let's look at the term hazardous area classification. Okay, so like I mentioned, this is a process safety course, right? And the essence of this particular topic is to look at the hazards involved in oil and gas. Okay, so we are looking at the hazards involved. What happened to this?
Myself,
Okay. Sorry, I was not seeing you again. So
I'm here. Yeah.
okay. So we are looking at the hazards involved in a plant, right? And how we can minimize those hazards, and then actually ensure that no explosion occurs, no accident occurs. Let's forget about accident, no explosion occurs, right? So in a plant, there are various barriers to prevent accidents, right? Now, this hazard area classification is one simple barrier that is used to prevent an accident, especially when there is a spill, right? This particular cause will not prevent a spill, so a spill can occur. But then, if that spill occurs, what is going to prevent it from blowing up? What is going to prevent that spill from causing a fire incident, right? So that is what we're going to look at today. Now, this topic has been, especially for operators, you know, this is something that is always overlooked, because as an operator, you don't have an idea of this particular area, this hazard area classification. You don't have an idea, because by the time you get to the plant, everything has already been installed. Both all the transmitters, the pumps, all the equipment have been installed, right? So what you're going there to do is just to operate, and then you focus on the other barriers, like the safety instrumented systems, the normal control barriers that you have in your plant, using your control valves to ensure that you control so that nothing happens, and then also the operator experience in also trying to prevent accidents. So those are the areas operators actually try to manage. Also, let's also use the for your tank farm, like the dike. Okay, so we try to curtail any spill using your experience. But this particular one is something that has to do with the process safety guides. This has to do with during the selection of equipment, right? So the type of equipment that is being installed in a plant can either enable a fire incident to occur, right? Just take, for example, when your pump gets very hot to an extent that it can enable a flammable gas to catch fire, right? That's the problem. Now, gas selection of that pump so that it doesn't cause a fire incident is part of this hazardous area classification. So let's follow the slides and let's see uh, what this topic is mainly all about. So, what is hazardous area classification? Now, it is the systematic process of identifying locations in an industrial facility where flammable gases, vapors, or combustible dust may be present in quantities sufficient to cause fire or explosion. So the first thing you do is to identify the locations. where these flammable gases are present that can actually cause fire. Okay. Now there are different zones. When we get to the zones, we'll see that. But then the first thing you do is if you go to a plant, right? Or if you have the layout of the plant, the first thing you do is you categorize the plant into various regions according to their flammability limit. Okay, so that's the first thing you do. Now, after you do that, the next thing is to prevent ignition of these gases by controlling equipment used in those areas. So you understand the gist now. So this is exactly what hazard area classification is all about. You identify the zones that you have all these gases. Now, before you identify the zones or the gases, it means you must have an idea of the kind of gases or the kind of fluid in that area. So take, for example, for a refinery, you know that you're going to be having your diesel, your naphtha, residue, you're going to be having your LPG, right? And some other forms of gases, your H2S. Okay, now, the next thing you need to know also is what is the flash point of these gases? At what temperature are they going to vaporize? Right? So, in summary, the hazardous area classification is a study that enables you to locate these gases, enable you to map out all these the areas where these gases are available, and also position equipment that will be able to prevent explosion. You understand? So let's move forward. Now, why is HAC very critical in oil and gas? Now, you know, hydrogen leak can create explosive atmosphere. So if hydrogen is allowed to leak, and for sure, you can prevent it, but in the long run, you know, after a long time, you're going to have leaks from your flanges, from your vents, from your drains. You get, so you are going to have leaks at some point in the life of that refinery or the life of that plant. So how do you prevent that leak from exploding, right? That is the essence of this study. Now, electrical spark also. You are connecting wires together. Definitely, there's going to be a surge and there will be a spark. So if there is a spark, how do you prevent that spark from causing an explosion? Okay, now there are going to be incorrect equipment selection. Okay, so incorrect equipment selection has caused major refinery disasters. Okay, so what this is saying is that by selecting the wrong equipment and placing it in a particular region can cause disaster. So if a pump is operating at a temperature of let's say 40 degrees, right? And then we have a gas that is supposed to that is going to vaporize at a temperature of let's say 50 degrees. It means that place is safe due to the selection of that equipment. But what if you bring an equipment that when it's working is going to get hot to a temperature of about 60 degrees? Meanwhile, you have a gas that can ignite at 50 degrees. What's going to happen? There's going to be an explosion whenever there is a leak of that particular gas, right? So selection of that pump, that equipment, is a very critical criteria and is one of the things that actually causes explosion, because most of the other barriers can be controlled by the operators. But you see, this equipment selection cannot be controlled by the operators. So if there is no process safety personnel on ground to always be checking on all these things, there's bound to be explosion, right? So the HAC ensures that proper equipment specification is done. And this is done, you know, during the design phase, right? So the next is, let's look at examples of a refinery offshore platform explosion risks. Now your tank farm, your storage chamber vapor release, we have pump leaks. So at your pump, you are always going to have leaks because you have drains, you have flanges, and those flanges, most of the time, the gas that's inside can get worn out, and then before you know it, you start having some leak. Okay, and then you have your process vessel. Every vessel is going to be having a vent and also a PSD, right? But that vent, maybe the valve that was used to lock that vent can get corroded, and then you start having leaks. So all these are things that will cause explosion if the equipment are not selected properly. All right, so we have what we call LOPA. I believe this you can relate. So
Yes,
LOPA,
of course.
yeah.
Yes.
So like I mentioned earlier on, we have various layers of protection in a plant, right? Various things that tend to protect the plant from exploding. And as you can see the image, you see this explosion at the top. So if all the layers from down you get to the top, if they are not functioning properly, you are going to have this explosion. And the last line of defense is your emergency response. That's when everything, the plant is exploding. So how you respond to this emergency is there. But if you look at this looper, you notice that the hack is not showing here, which is why I say the hack is something that is always overlooked, right? So we have your plant design. So during the design phase, a lot of barriers are put in place to prevent accidents, right? That is understood. Now we also have what we call basic process control systems. So these are your control valves and all the rest. You want to use to open and close, ensure that let's say the downstream or the upstream, they are not pressurized, everything to function smoothly. And then we have operator intervention. So this one has to do with the experience of the operator. Okay, so if something is happening, the operator can quickly go there and rectify it. Then we have a safety instrumented system, which is your SIS. Now, if your SIS senses that something is going wrong and then operator is not handling that issue, right? The SIS takes over automatically, right? Let's take, for example, if you have a low level or a high level of a storage tank or a storage vessel, the SIS is going to take control and then ensure that it shuts down that area so that the accident does not happen. Then from there, we go to your relief valves, which is your PSVs and all the rest. Then we go to your dike. For a tank fan, we go to the dike. So the dike is when there is a spill, it tends to prevent it so that it doesn't extend to other regions where fire can occur. And then we have the emergency. But like I said, the hack is not here. Okay, now the hack can actually be part of the design phase. But then, as an operator, if you look at this, you see that that is missing. Okay, so let's move forward. Now, before an explosion can occur, it means there is what we call fire, right? And then for fire to also occur, there is this thing we always know, this triangle, right? The triangle of fire. Okay. So for this triangle to be complete, for it to be complete, for fire to occur, we need oxygen, we need fuel, and we need heat. Okay? So we know that oxygen is always available. And then the fuel now is the spill. If there's a spill, if there's a leak, that's the fuel, right? So the next thing is your heat. So what is your heat source? Of course, operators will not go and light fire, right? Operators will not, when they see leak, they will light fire to say, okay, let's test and see if this thing will explode. No, so something is causing that heat. Now, what is causing that heat? Your equipment, right? So the surface of your equipment can cause a heat that will cause explosion. So whenever there is a leak, if you watch, whenever there is a leak, especially like let's say gas leak, and then there is a vapor cloud, right? What usually causes that explosion is either the heat from the surface of an equipment or let's say a spark. Most times from vehicles, some people will just be driving vehicles when there is a vapor cloud, and that spark will ignite, and then everything will explode. So if you can stop this heat from occurring by selecting the right equipment, then you have saved that plant from exploding. Okay, so explosion requires three elements. We have the fuel, we have the oxygen, we have your ignition source, your spark, your heat, your static electricity. And then the hack focuses on controlling this ignition, which are these things we just mentioned now, right? So hope this is very clear.
Yes.
Okay, sir. So yeah, let's move forward. Okay, so your ignition sources in your industrial facilities. Like I mentioned, we have electric sparks, and then you see your electric spark is coming from your junction box, most likely your box, right? Because that's where a lot of naked wires, they are being connected in a box, right? So if there's any spark, it's going to be in that junction box. So there can be a spark, but what if something can prevent, can prevent the spark from igniting the vapor outside, right? That's why selection of your junction box is very, very important. So there are different grades of this your junction box that can be selected to prevent any spark, right? So that is why you need to know this hack very, very well. The next thing is your hot surfaces, so like your pumps. So I think I've explained this. If you look at a pump that when it's operating, the temperature is going to be above the ignition temperature of a particular vapor in that region, then it's going to cause fire. So we have static electricity, we have mechanical friction. So most times this friction occur at your pumps. What's it called? What's the name of this rod? This part that rotates on a pump.
The impeller.
The propeller?
The impeller is the inside.
Impeller, okay.
The impeller is the inside. The rod itself, the connecting rod. That connects
the shaft.
Yes, the shaft. That connects the motor and
The shaft.
Yes, so that's the shaft. So most times
The shaft.
Yes,
That's the shaft.
Yes. Most times those the shafts they rub, there are parts that rub each other and then from there generate heat. So that heat can, cause fire incidents, right?
Yes.
And then we have your open flames, we have your lightning. Okay. Now some of them we cannot control them, especially like the lightning. Can we control lightning?
No.
You can use most times you can use arrestors. So I think your equipment can be connected to your lightning arrestors, right? And I believe that can also prevent it. But there are some lightning that you can't actually control. They will come in very heavy and then they will damage everything. So if you want to get more idea on this, we can follow some of these standards, right? So IC 60079 ATEX directives, we have API ROP 500. We have API ROP 505, and then we have the NFPA standard. So these standards will give you more guide on how to carry out this HAC selection. So I think let me see. I think I have I have API 500 here, and then I have API 505. I'm not sure if I have NFPA. Okay, no, so I don't have NFPA. Okay, but I think I have IEC 60079. Okay, so if anybody needs this standard, you can chat me up after this. Okay, so moving forward. All right, so how do you approach the hack? How do you carry out this hack? There are various methods you can use to carry out the hack. We have the point source. Now this point source is if you know the whole size, right? During that release, right? If you know the whole size where the release is coming from, then you can use this point method where you can get different points. And I think this is what they use for these simulations, these models they use for simulations. And then we have the risk-based approach. For this one, you don't know the whole size. Okay, so you can use that method, but then you can also use direct method. So this direct method is a very good approach, and I think that's what we'll be discussing on in this course. So let's look at the direct method. So how do you carry out a direct method? So we are going to be following these steps one after the other till we get to the end. Now, the first method here is to identify the hazardous substance. So that's the first thing. So whenever you get to a plant, the first thing is you know what is going to cause hazard, right? You know the chemicals or the gases involved, right? And these are mostly the highly vaporized gases that you can look out for. So the next thing is you determine the gas group. So these gases are grouped into various groups. So we look at the groups, then you determine the temperature range. So the temperature is the temperature of equipment, right? You look at equipment that operate at various temperatures. And then also we look at Okay, so when talking about the temperature, we're looking at also the flash point of the gases, right? So that any equipment you are placing in that area will not be more than the flash point of that gas. Then also we're going to look at the identity to identify the leak source, and then to determine the release frequency, then to classify the zone, and also determine the zone extent. Then finally, you now select the equipment that is going to be in that region. So by the time you finish all these ones, then you are done with your HAC. So the last one is just to identify the equipment. So by the time you identify the equipment, then you are done with the HAC. So let's start with the first one. So the first one is to identify the flammable fluid. Okay. So depending on the facility you're looking at, if you're looking at offshore facility, we are going to be having crude, right? We're going to be having we're going to be having your gases at the gas compression train. So we are going to be having some chemicals that you use. But I think the most severe one is your gas, your methane gas, right? Then if you are going for refinery, you are going to be still having crude. Then your products, you have naphtha, diesel, residue, fuel gas, LPG, then let's say kerosene and other products. So flash point now. Now the flash point is the lowest temperature at which your vapor can ignite. Okay, and then the lower your flash point, the higher the explosion rate. So if your flash point is coming down, let's say from 50 coming down to 40 to 30, the risk is very high because any small heat can ignite it. Imagine your flash point is about 20 degrees. That's almost lower than the atmospheric temperature. So it means at any point that gas comes out, there's an explosion. So it's very important you know this. Then for naphtha, it's very hazardous. For diesel, it's moderate because diesel is a bit thicker, so a bit denser, so it's not going to. I think the flash point for diesel should be around. Okay, naphtha should be around. Let's say is it 120 or so. Then diesel should be around 160 to 180. Right. So before a pump or before an equipment can get hot to up to that temperature to explode, it's going to take a lot of time. But for lighter gases, it's going to explode immediately. It comes out to about, let's say, 80 degrees. Then there's going to be an explosion. Okay, so now let's categorize these gases in their groups. Now, flammable gases are divided into groups based on their ignition characteristics. The first one is group IIA. So group IIA, those are the gasoline, your methane, your propane, your acetone, and then your ammonia. So these are categorized in this group. Now, pay attention to this group because it's very important. Now, if you go to any plant and then you look at their equipment, if you look at their transmitters or their pumps, right, you're going to see something like this. You're going to see something written II, then you see the value there. It's going to be IIA, IID, IIC. So this is going to tell you the kind of gas or the kind of let's say gases that we have in our region. Okay. So IID is for acetaldehyde, ethylene, ethylene glycol, or H2S. And then group IIC is for hydrogen and acetylene. Okay, now IIC are the most severe, right? They are the most severe gases. So if you want to place any equipment that is having hydrogen, then you have to look for equipment that has this IIC tag. Okay. Now the severity increases from IIA to IIC. Now it means that if you have equipment in IIC, you can also use that equipment for IIA and IIB. But you cannot use equipment for IIA to work in IIC. Okay, so this is what this other statement here is meaning. Equipment designed for IIC cannot be used in IIA and IIB, but vice versa. So meaning if you have equipment and then equipment is showing you IIC, that's like the highest standard. So you can use that IIC to place in areas that have IIA or IIB. Okay. All right, so let's look at temperature classes. Now, electrical equipment must not reach surface temperatures capable of igniting the surrounding gases. Okay, so if you place an equipment in a particular region, the temperature, the surface temperature of that equipment should not be more than the flash point of the surrounding gases in that region, in case there is a spill. Okay, now the temperatures are also classified into various tags here. So you have C1, which is 450 degrees. You have C2, which is 300 degrees. You have C3, 200 degrees. C4, C5, and C6. Now, C6 means that that equipment will not get hotter than 85 degrees. It will not get hotter than 85 degrees. So if there is any gas that will vaporize or that will ignite at about, let's say, 100 degrees, then you can use an equipment with C6 to place in that region. Okay? So I know it's getting a bit, I don't know if it's getting a bit confusing.
No, it's okay. We understand. Go ahead.
Okay. All right. So
Go ahead.
Yeah, so let's move forward. So this temperature class is telling you that, okay, the temperature, if it gets hot, it should not be more than this particular temperature. It should not be more than, for C1, it should not be more than 450 degrees. If it's hot, it should not get more than 450 degrees. For C2, it should not be more than 300 degrees. Okay, so with this, you can know where to place that particular equipment. Then we have to identify the release. Okay, so the release source is the locations where there can be releases, right? So the first one is your pump seal. So we know your pump seals, after a while, if the seal gets a bit whole, it will start leaking out. Then your compressor seals also the same thing. You have your flanges. So at various locations of your pipeline, you have different flanges, right? So those flanges, they are connected, and then we have gaskets inside. So the gaskets can get worn out, and then you have leaks. And then we have your sampling point. So where the lab guys will always go and take their samples. That region can also cause accidents. Then we have, yes, then we have your tank vents. Okay, so your vents for both your tanks, both your separators. So that region is also prone to explosion. Yeah. And then we also have your drains, right? So your drains, most times during operation, you tend to open some drains for some vessels just to allow water to come out, right? Why the water is coming out is bringing out gases, vapors also. So that can also lead to explosion or accident. Okay, so the same thing as your release source. So I think we talked about this. And then the grade of the release. So this grade is very important. With this grade, you can now zone your facility. Okay, so you can now carry out your HAC layout, and then you draw using your AutoCAD or any tool that you want to use to draw out the layout of your plant, and then you include all the zones. So the first one is your continuous release. So what does it mean, continuous release? It means at every point in time, that vapor is released. It's always there. It's released. Okay, and then it means that place is always prone for fire accidents. It's always there. So that's continuous release. And then if you want to zone this is zone 0. Okay, but we'll get to this. And then we have the primary release. The primary release is during your normal operation, when you are operating, right? Everything is stable. But then there is likely, especially for the leak, there is something going in that region. So at every point in time during operation, even if it's normal operation, that is prone to explosion, right? And then for the secondary release, this is only when there is, or let's say, offset in your facility. When there's an offset, then this is called secondary release. Now this is your zone 2. Your primary release is your zone 1. Your continuous release is your zone 0. Okay. Okay, so let's look at the zone. So your zone 0 is flammable atmosphere present continuously. So let's say, for example, your storage tank, right? You have crude in your storage tank. Now, even if you're on shutdown, that crude is there. Now, as long as that crude is there, we have lighter gases that are always in that region, right? So it is continuous. It's always there. Your product tank, the same thing. Your storage, as long as you have a storage and then something is inside, it is prone for accident at all times. Okay. Then your zone 2. So your zone 2 is something that is likely during normal operation. Okay, like I explained earlier on. So let's say your pump, right? Your pump is actually taking in fluid and then sending it out during operation. It's normal, everything is normal, but then since it's working, there is prone to be a leak at the flanges, okay, or at the seal of the pump. So all those leak areas and those seal areas, they are prone for accidents. So those areas are in zone 1. So when you're doing your layout for your plant, you know the areas to put as your zone 0, your zone 1. So your pipelines are zone 1. Your storage tanks, your vessels, they are zone 0. Okay? And then your zone 2, they are areas that can cause accidents during abnormal conditions. Okay, so where can this happen? Let's say your drain. Let's say because during abnormal condition, you need to open your drain, you need to open your vents, your PSV. Okay, if your PSV is directed towards your flare or your flare header, then you know that your zone 2 is going to be at your flare stack, right? Your knockout drum, your scrubber, or your flare stack. That's going to be your zone 2 because it's only when there is abnormal condition that there is going to be a release. Okay, but you know some refineries, even their PSV, they open it to the atmosphere, they vent it to the atmosphere just to depressurize the system, right? So this is your zone 2. So when you're carrying out your HAC layout, you understand what I'm saying? Because I think you have a project for this.
Yes, yes.
Yeah, so this is very important. When you carry out your layout, you know that your zone 0 is your tank, right? So if you are looking from the top, the circumference of your storage tank inside is your zone 0, right? But then the surrounding of your tank is now your zone 1. Then all the pipe rack, your pipelines and all the rest, you use them as a zone 1. But then you now locate your zone 2 as those areas that are vented out during abnormal conditions. Okay?
Yes.
All right.
All right. So yeah, so this is the symbol for zone 0, zone 1, and zone 2. So while carrying out a layout, if you go to a location where you have zone 0, you use these circles to just circle around. So that's your zone 0. And then your zone 1 is this other one you're seeing here. And then your zone 2 is you use this other symbol. Okay. Oh, what did I do? Sorry.
The symbols.
Okay. So I think we are done with this. You understand this, right?
Yeah.
Yes, yes.
Okay. So let's look at a simple example now for a petrol station, right? Okay, so you see on the ground we have your storage tank on the ground.
Storage tank.
Yes, so for the storage tank, we have your liquid inside. Let's say your fuel or your diesel, anything that is there. Now at the top of the liquid, we have gases, flammable gases at the top. So that flammable gases at the top that is going outside the tank is your zone 0. Okay. Now, like I said, it's zone 0 because it's always there, it's continuous. As long as we have product inside the tank, we're going to always be having that. Okay, so that's the zone 0. Then your zone 1. Okay, your zone 1 is your transfer line at the pumping unit where you do the pumping and where you are putting in the PMS inside the vehicle. And during unloading at the surface of the let's say the manhole for the trucks, right? So this area is your zone 1. Now your zone 2 is when you have an offset. Let's say when the tank is filled up and then the thing starts spilling out. Now the surrounding will now become your zone 2. I hope this is clear.
Yes.
Okay.
Yes.
It's
So
clear.
all right, thank you, sir. Let's move forward. Okay, so the essence of your zone is very simple. Like I mentioned, your zone 0 is inside your vessel, right? So as you can see here, zone 0 is inside the vessel. Your zone 1 is just 1 to 3 meters at the location where your activity is going on, or at the location where your zone 1 is. Sorry, so your zone 0. Okay, so for your tank, your storage tank, 1 to 3 meters in that surrounding is your zone 1. So when when carrying out your layout, just keep a space of 1 to 3 meters, and then circle that place as your zone 1.
Zone 1.
Yeah, and then for zone 2, 3 to 8 meters. You understand?
Yes, sir.
Okay. Now, things that can affect your zoning are your ventilation, the pressure, the gas density, the release rate, and then your wind speed. Okay. If you have high wind, it means it can actually spread your gas. So by the time you spread the gas, it will extend the zone. Instead of 3 meters, it might extend it to about 4 meters or 5 meters. So when you're carrying out your analysis, your layout, also try to think about the wind speed of that region, right? If the wind speed is high, you can note it down that okay, the wind speed in this area is high, so which is why my zoning I tend to extend to 4 meters for like zone 1, and then maybe to 10 meters for your zone 2. So ventilation is also a criteria there that affects your zoning. Right, so you can look that up. So for ventilation, you say good ventilation reduces hazardous your zone size. Okay, then poor ventilation increases your zone size, and then indoor facilities require special analysis. Okay, so if you have ventilation, it can reduce your zone size. So let's say, for example, inside the tank, we have a lot of ventilation. So since you have a lot of ventilation, your zone 0 is going to be reduced because it's venting everything out to the atmosphere. And then by the time it vents it out, the surrounding is going to be your zone 1. So it's moving your zone 0 to zone 1 because ventilation is now pushing everything out faster. So that's that. Now, the final thing here is selecting the equipment. Okay, so by the time you finish doing all these other ones, the next thing is which equipment will I use at this location? Now you know that okay, this area is zone 1. You know that this area is zone 0. What equipment is perfect for zone 1? What equipment is perfect for zone 2? And what equipment is perfect for zone 0? Right, so we are going to look at the selection here. So equipment must be certified for hazardous areas. Electrical equipment installed in hazardous areas must comply with explosion protection standards. Example, we have the ICEX, we have the APEX, then we have the NEC. Okay, now, based on this standard, they classify equipment into explosion-proof motors. Okay, flame-proof junction boxes. We have intrinsically safe transmitters. And then we have explosion-proof lighting. So we are going to look at all these one after the other. But then let's look at one example. You see this example we have here, EXGIIB-E4. Now, if you look at this, right, you notice that we talked about IIB. That is your grouping of your gases, right? So IIB means what gas is located in that region. So you see that selection of the gas now, understanding the type of gas or the vapor we have in that region is very important. It's part of the things that enable you to select your equipment. The next thing is the temperature now, which is the T4, T6, T1, T2 that we talked about already. And then we now have the EXG. Now, EXD means something. EX means exclusion proof, right? But the D also stands for another thing. So we are also going to look at this. Now, you see this marking, this is equipment marking rating for ATEX, right? Now, let's look for a good example. Now, this equipment you're seeing here is a fire detector, flame detector, sorry. It is a flame detector. Now, if you zoom into this flame detector, you see this code. You see the right up there, EXZ11C6. Let me zoom it in so that we see. Oh, I think it's not really very clear. But it's here. Let me show you here.
The more you zoom in, it becomes
It
blurred.
becomes blur, yes.
Yeah.
But it is here now. Yeah. But this is, you see here, this is I, this is C, and this is T, and this is 4. Okay, here is EX. So that's the code that I use to place down here. So the same code you see here, ESD IIC C6, right? So why is it ESD IIC C6? You know, I mentioned earlier on that the IIC is the most severe. Okay, so if you have any equipment that has IIC, you know that that equipment can function both in IIA and IIB, right? So selecting this one means you are selecting the most safest equipment, right? That can be used in any region for any gas leakage, right? Then we have the T6. I think T6 is the temperature is about 85 degrees. So it means this equipment cannot get hotter than 85 degrees no matter what. So it's also safe because this equipment is meant to detect gases, right? If there is a leak, it's meant to detect any gas. Now, if this equipment is meant to detect the gas, and then by the time the equipment is hotter than 100 degrees, it's going to cause a flame. So you need to select an equipment that will prevent or will not cause any explosion, right? Which is why they use this particular equipment. So understand that this is something very practical. Okay, this is how they select the kind of equipment that they place in a particular place, right? So the next is let me know this. Okay, now like I said, we have EXD. Now I mentioned that EXD, that Z stands for something else. Now the EX stands for explosion proof, right? But this other tag, this D, this I, this E, P, and O also stand for other things. So the D stands for flame proof equipment. So it means it protects the equipment is flame proof, right? And then the I stands for let's see, intrinsic safety. The E, if you see E, it means it is increased safety. Okay, so the E stands for equipment that has an increased safety ability. And then if you have P, it means the P is for pressurized region. So it means it can put this thing for something like a boiler that has high pressure, right? So all these things are very, very important. Then we have the O. So I think the O is for optical radiation. Then we have C for protection by enclosure. So if you are selecting an equipment, you need to know the region you are going to be placing the equipment. And with that, you now know the kind of equipment that you select. Then as an operator, if you walk down to your field, it's very important that you check all these equipment and you confirm that these equipment are meant to be in those regions, right? So let's say, for example, you have a pump that is working at your naphtha region. Okay, so if your pump is working at your naphtha region, you know that since naphtha is coming out, if naphtha is leaking out, it means that there are going to be other lighter gases that will come along with it. So placing an equipment there means you need to place an equipment that is safe, that is intrinsically safe, or that has increased safety. So you can have the one that has this E or I that is placed in that region. Okay, if you look at pumps usually have this EX. If you look at the motor of the pump, it has EX. So EX means it is explosion proof. Okay, so all these are what we now know as the HAC. So the first one is the EXD. So EXD means flame proof protection. So if you see EXD, it means it's flame proof protection. So equipment enclosure withstands internal explosion. So if you look at this junction box here now, what this means is that if there's a spark inside the junction box now, the casing is protecting it from, coming to the surface. So it will not cause any explosion if there's a spark inside. So you don't just pick any box and then take it to a region where if there's a spark, it will, ignite. You take something that is protected. So which is why this is flame proof protection. And then we have another one, the EXI. So EXI is intrinsic safety. Now the intrinsic safety is mostly for these transmitters. Transmitters, we have the switch box, and then also this junction box. So you can see this is boldly written intrinsically safe circuit. Okay, so this is used for both transmitters, sensors, and then your control loop. And then the next one is your E. So your E, you can see your motor, and then this is your junction box, and also, so this is your P. So I think the P I said is for pressurized region. So you see this, I think this is a boiler also. So this is placed close to a boiler because it can withstand the pressure. Okay. And then also, okay, so I think that is all. So let's look at a case study. Okay, so let's use a case study. All right, so we are going to be using a refinery. So we use a refinery, and then let's go to, yeah, so this is like a small overview of a refinery, okay? A small refinery that has a tank farm. There is a tank farm here. And then for your tank farm, you have crude. You have, let's say, residue. You have diesel. You have naphtha. Okay. So if you want to draw your layout now, what do you do? For the crude, all these places is zone 0. So you just use your circle to circle inside to indicate that this is zone 0. So all the inside here, they are zone 0. So you can have a top view layout, and then you have an equipment by equipment layout. So for that, you take every equipment and then you zone the equipment too. You understand? So for a tank, you take the side view of the tank, and then you now zone the surround, look at the whole view, and then you zone inside the tank and then within the tank too. So this is it, tank farm. And then we have the pump station. We have the processing area. So this is where we have your furnace, your distillation towers, you have your reflux drum separators, your gas separators, you have your heat exchangers, and all the rest. And definitely you are going to be having a lot of vapors here. So, knowing how to zone this area is also very important. Then we have your flare. So I think I said the flare is most likely when there is an offset. When there is an offset, this is going to be your zone 2. Most likely your zone 2. But during normal operation too, you can have zone 1 in this region. So you have your utilities, where you have your compressed air, your instrument air, your nitrogen generation unit. Okay, so this area is likely not prone to any accident. So you can just zone all this side as zone 1 and zone 2. And then this is your boiler. Your boiler, you use depends on what you're using for your boiler. If you're using gas boiler, you're using diesel boiler, you're using electric boiler, then you know how to zone this area. And then you have your loading and unloading arm. So like, we look at the fuel station, the same thing as you're loading and unloading arm. During loading, you're going to be having some vapors, coming out. So that's your zone 1, and then your zone 0 is going to be inside the truck or your tanks, which is here. So this is just a case study of how to carry out your zoning. The next is we can move on. Okay, so for tank farm, we have your crude oil tanks, we have your diesel storage tanks. So I think we talked about all this. And then you're going to also be having transmitters. So you know what kind of transmitter you're supposed to be using in this region, right? And then, okay, like I mentioned, if you are carrying out your zoning, right? So you do your top view and also you do your side view. So this is the side view of a storage tank. So you look at the way it is now. This is your tank, and then inside the tank is your zone 0, and then you see that outside at the top is your zone 1. Then at the other locations you have your zone 2. We have what we call a sump. So this is a sump. Yeah, if you want to drain water from the tank, you drain it into the sump, and then from there they decant the crude oil and then send it back to the tank. So at your sump here, you also have zone 0 and zone 1 at this region, right? So that's that. Your equipment. So you look at explosion-proof level transmitters, you look at intricately safe transmitters, you look at flame-proof lightning, and then your cables also. So for your pump station, crude loading pumps, your diesel transfer pumps, your naphtha pumps, your manifold, all these areas are prone for accidents. So you know how to zone this area and what equipment to put there. Yes, anything, any questions?
No, I think that may be just be an
Can you hear me, sir?
Yeah, I can hear you.
Okay. Maybe before, as an operator, maybe before I will be, maybe when they will employ me to work in the control room, then they must have installed all these instruments and equipment that they are talking about. So how will I now come and tell you that maybe this particular instrument that you put here is not supposed to be here? Would they listen to me as an operator?
Okay, so I think we talked about this earlier on before we started the main thing. So as an operator, why you need to know this is that, like I mentioned earlier on, all the other safety barriers, you as an operator, you can handle them, right? But then this particular one, you cannot handle it because why? Before you get there, they have already installed everything. But if you as an operator, you have the idea that this pump you're using here is going to cause an accident, are you telling me that if you advise the management, they will not listen to you with facts? Definitely they will listen to you because you tell them that, okay, this machine, this equipment is not meant to be positioned in this region. You can get your code from the IEC or the APEX that we just mentioned, and then you show them with evidence that, okay, you see this code we have here, this temperature is showing that this machine is going to be operating when it's hot at about 300 degrees. While we know that the vapors are going to be having, if there's any leak in this region, the flash point of the gas we have here is about 150 degrees. So if there is a leak and this temperature of this pump is about 300 degrees, it means there's going to be a fire and there's going to be accident. So there's no way the management will not listen to you. In fact, they will even applaud you. So which is why it's very good that you understand this particular, because most operators, they don't have the idea that simple equipment like your transmitter can cause an accident. Because let's be honest, when there is a fire in a refinery, if you do your investigation properly, you know that it was a spark or an equipment that was hot that caused that fire. So if you can bring in evidence to show the management that, okay, if we do this, we can prevent total accidents to happen in the future, then they will listen to you.
Thank you, sir.
Hope you get it. All right. So yeah, we pump station hazardous zones. Okay. Okay, so just look at an example here again. This is another simple example. We have a loading gantry here. So if you look at the loading gantry, your zone 0 is inside the truck and then from the loading arm. Okay. Also, if you look at the storage tank at the top, you see that it is inside the storage tank. Okay. Then your zone 1 is just within the periphery of that your zone 0. Then the rest area, about let's say 3 to 8 meters wide, is your zone 2. Okay, so this is very clear for you to understand, right?
Yes, yes.
Okay, so this is another overview of what we're talking about. And I think at this moment, okay, like I mentioned, the utility section doesn't have a lot of hazards, so that area can be ignored. But you can also just tag them as zone 1 or zone 2. And then your flare station is most likely when there is an offset. Although when, like for gas plants, right, for gas plants it is continuous, so you can zone it zone 0, right? Because for gas plant, they use your flare to actually uh, control the amount of gases they're actually refining. Okay, so for this one, you can target as zone 0 and zone 1 and even zone 2. But if you get to some refineries where they are refining less gases, so we don't have a lot of gases going to your flare. Now it means the only time you have gases there is when there is an offset. So you just zone it as zone 1 and zone 2. Okay. All right. So benefit of proper HAC. Now, proper HAC will prevent facility explosion. It will protect the workers. It will ensure that correct equipment selection is done. It will enable the company to comply with a safety standard and then improve plant reliability. But another thing that it can also improve is cost. Okay. So when I mean cost is during the selection of this equipment, somebody can decide to say, okay, let's just take the highest grade. Let's take the highest grade of equipment to install. Now, buying the highest grade means you are buying something very, very expensive and it's going to cause the company to spend a lot of money. But if they can be able to carry out the HAC and then know the exact equipment, because you can't, some regions, they don't even have hazard. So you can just, take in a lesser one and then install in that region. But for somebody that just say, okay, let's buy all of them high grade, they will buy all the high grade and then they will just install everywhere. And then the company just spend too much money. So with this HAC, you can be able to know the exact equipment to be used. So conclusively, hazardous area classification is critical for refinery, offshore, and all facility safety. And then correct zoning ensures proper equipment installation. It ensures that ignition sources control is the main goal. And then engineering judgment and standards are also applied. So I think we are going to stop here. But then, Mr. Gibbs,
Yes, yes.
as usual, we are
So,
going as usual,
yeah,
we are going to have
this is
assignments.
okay, and I can begin reviewing. But when we are done, you could send the projects later on.
Yes, I have two projects. I have two projects for you. So I'll send two assignments anyway. I'll send for you after the class.
Okay.
Yeah. So,
Someone is Anthony. Anthony wants to speak.
Mr. Anthony, go ahead.
Okay, thank you very much, Nat. I'm happy that I was able to join this class. I was just in the group and I saw the link. Okay, so so much vital information you've shared. But I just have a question.
Okay.
Okay, so I don't know if I'll call it a question. Okay. Your classification of hazardous areas is very clear. But the only issue I have, that zone 0 classification. You mentioned that it is inside like your storage tank.
Yeah.
Your storage tank. So well, I'm looking at your storage tank. Inside the tank itself, normally you don't even have oxygen. One of the things you do is to completely expel the oxygen from inside the tank. Of course, you have vapor. So the chances of you having explosion or a flame inside
the tank itself is reduced. But now where you have problem is that around the immediate vicinity of that tank, you have continuous presence of those flammable hydrocarbons, if it is hydrocarbon that storage tank that you are looking at. So I was thinking that the zone 0 is that immediate vicinity where you have that continuous presence of hydrocarbon flames, and there you already have oxygen because it's exposed to the atmosphere. But inside the tank, you don't have oxygen because one of the things you do is you first of all make your tank inert before you even start to use it. You remove all oxygen before you start to use it. So I don't know. So I was just thinking if this zone 0 is within that immediate vicinity of this, because from my experience, that's our storage tank. The immediate vicinity of the storage tank, everything is done to make sure that any kind of ignition will not be present there. And then even when you have the issue of thunder, they try to come up with lightning arrestors and other things to prevent. And then you have sufficient firefighting equipment to make sure that even when you have an explosion, and when you have an ignition source, you try to prevent serious fire. So that's just what I'm thinking. So I don't know if maybe my idea of it is a bit wrong, or maybe I did not really get your explanation well.
Okay. All right. Thank you very much. Okay, so I would say that your observation is quite correct. But then, you know, your vessels, you can't completely remove oxygen from it. You have breather vents. You have breather vents that are open. So there's no way you tell me that oxygen will not be present. At least a very small amount. That if there is anything inside, it can cause accident. If there is, let's say, a lightning can cause accidents inside the tank. So that region, like I mentioned, zone 0 is when you have continuous release. So from your level of your tank, so if you have, let's say you have crude inside your tank, and then the crude gets about 50%. From that 50% down to the top of the tank, there are a lot of hydrocarbons inside. A lot of hydrocarbons inside. And then if you get to the atmosphere, you see that the hydrocarbons outside they are reduced. Reduce a bit, okay? So quantity inside is very high, which is why it's very severe, which is why it is zone 0. Because zone 0 is where we have a very severe chances of an explosion. Now also, you know, although they use some radiographic transmitters to, you know, place on your tank to measure the level of your tank, but that is also an equipment that is there. Okay, so your zone 0 is most likely inside your vessel. Inside your vessel. Then the atmosphere, the surrounding atmosphere is a zone 1. From the external walls of the tank to about 3 meters is a zone 1, while from 3 meters to about 8 meters is a zone 2. So that's the way I understand it. And if you feel otherwise, then maybe we can just go back and do some more research on that.
Okay, thank you for this. No problem. Your explanation, I think, is correct. I was just thinking that because even when you have your transmitters are usually you may have the probe extending down there, but the transmitter is at the surface. And most times, yeah, you have breather vents. But no issue. Maybe I will just have to make more research on this so that I will be convinced myself.
All right. Thank you very much. Any other maybe contribution? Any other question?
Okay, in absence of none, we appreciate those who joined. Make it a larger quorum and an interesting session. And thank you, Matty. This is great. We appreciate your time as usual.
You're welcome, sir.
Okay, sorry, Nati, one more thing. I know it seems this class was actually designed for a particular person. So those of us who joined, is it possible we get this slide?
A slide.
Yes. So is there any, can we get any evidence that we partook in this training too?
No, this is just a group discussion, so it's not meant for you to show anybody that you partake in the training. So there's nothing like certificate. There's nothing like. But I can share the slide.
Okay, so you don't, if I want to go and tell them now that I've done this training, you don't want me to show them evidence, huh?
You're a political person. Edom.
No, your knowledge alone is enough. Is enough.
Yes, you can get the slide. Organati will send to you.
Just reach out to me after now. Just chat me up, then I will send you the slide.
Okay, thank you very much. Thank you,
sir.
You're welcome, sir.
Thank you so much, sir.
Any training like this, just let me know. I'm always interested.
I will drop it in the group. Anything like this, I will drop it in the group. Yeah.
Thank you. We appreciate the beautiful work you're doing. Just keep it up.
All right, sir.
I want to be like you. I want to be like you when I grow up.
Yeah, I want to be like you too now.
Thank you very much.
All right, cheers, guys.
All right.
Okay.